Yeah. Mm. Yeah, start Aruna Devi.
Okay.
Yeah, others
Hi,
listen Aruna Devi applications on 8051 microcontroller. Okay, listen to her.
hi friends. Today I am talk about application of 8051 microcontroller in EVM. EVM is nothing but electronic voting machine. Why we are using EVM now? Avoid fake voting and it requires less manpower and automatic counting. Ma'am, next slide, ma'am. This is the block diagram of EVM. EVM consists of four blocks: microcontroller, control switch, LCD display, input keys. The EVM built with a transformer, bridge rectifier, voltage regulator, microcontroller 8051 microcontroller, push button, transistor, EEPROM buzzer, display. First we go for power supply. A 230-volt AC power supply is first step down by using transformer, step down transformer. After it converted into DC by using bridge rectifier. And then the AC ripples are filtered out by using these capacitors and it given to the input of voltage regulator. The output of voltage regulator is connected to 8051 microcontroller. In 8051 microcontroller, we get a constant 5-volt DC. Push buttons. Why we using push buttons now? The voter can poll the votes for candidates. Here we are using buzzer. Buzzer, if a voter tries to poll multiple times, a long beep sound is generated by buzzer. Here we are using EEPROM memory. EEPROM memory is most advantage. Why? They store the data in voting sum. An advantage of EEPROM is store the data in memory even after the power is turned off also. Here we are using 16 into 2 LCD. 16 into 2 is nothing but 16 columns, 2 rows. It is a liquid crystal display. It can be easily interfaced and controlled by these microcontroller using input-output pins. Ma'am, next slide, ma'am. This is the circuit diagram of EVM. The input part consists of 6 switches. 4 switches are active low. It connected in port 1 first bit to port 1 fourth bit and remaining 2 switches are connected active as a active low and it connected in port 1 0 bit and port 1 fifth bit. The start switch start or initialize the switch starting the voting system and stop switch initialize the ending the voting system. Here the 16 into 2 LCD, the polling results on LCD screen. Ma'am,
Yeah, ma.
that's enough, ma'am.
Yeah, yeah, very good, Aruna Devi. She had given a wonderful application in electronic microcontroller using EVM. So we people were, I think, you people have get a voting in the coming year. I think so. So you may understand during voting what is the inside the microcontroller. She have explained well, and she have taken the nice topic. Yeah, good, Aruna Devi. And next,
Thank you, ma'am.
Aarti, register number 1, Aarti. Are you willing, ma? Now you are going to take. Shall I share your PPT? Aarti, can you able to hear my voice? Any problem in your network? I think I can't able to Aarti's voice. Aarti, are you there? Yes, ma. Can you able to hear? Yes, ma.
Ma'am.
Are you going to take or not?
Yes, ma'am.
Okay, shall I share your PPT?
Okay, ma'am.
Okay. Now your voice is, I think, audible. So, uh, think.
Ma'am,
Yeah, ma.
என் வாய்ஸ் கேக்குதா மேம்?
கேக்குதுமா.
ஸ்டார்ட் பண்ணட்டா மேம்?
இது ஸ்கிரீன்ல உனக்கு தெரியாதுல்ல. I will share your PDF. I think there is a problem on opening your. Yeah. I think now can you able to see your PDF?
Yes, ma'am.
Yeah, tell me. Yeah, start Aarti.
Hi guys, today I am talk about application of 8051 microcontroller in medical applications. Patient health monitoring system with location data by GPS over GPM. The circuit, ma'am, next slide.
PP.
The circuit consists of power supply, GPS modem, GSM modem, microcontroller, temperature sensor, EEPROM, LCD display, keyboard. The application of microcontroller 8051 in medical application made changes in the medical field. The patient health monitoring system with location details by GPS over GSM is an electronic based on the application of microcontroller. It is designed for tracing the patient location such that it enables the facility to reach patient location quickly in case of emergency. The patient body temperature can be monitored wirelessly using GPS and a message.
Aruna Devi. Sorry. Aarti. Aarti.
Message can be sent to the concerned receiver. PCR embedded complete GPS receiver module which contains all function blocks from antenna input to serial data output. The output of GPS modem is in binary format. Ma'am, GSM modem. A GSM modem is a specialized type of modem which accepts a SIM card and operates over a subscription to a mobile operator. It's like a mobile phone. GSM modem is a hardware device that uses GSM mobile telephone technology to provide a data link to a remote network. D89. D89 is a D-sub. It is a common type of electrical connector. They are named for their characters of D-shaped metal shield. When they were introduced, D-subs were among the smallest connections used in computer systems. LCD display means liquid crystal display is a flat panel display or other electronics modulated device. Temperature sensor. Temperature sensor is an electronic device that measures the temperature of its environments and it converts the input data into electrical data and record, monitor or signal temperature changes. EEPROM means electrically erasable programmable read-only memory. It is programmable read-only memory that can be erased and reused. Microcontroller is an integrated circuit device used for controls other portions of an electronic system. If the temperature if the temperature of the patient's body increases behind the present temperature, then the temperature sensor sends signals to the microcontroller. Thus, the microcontroller activates the GSM modem to send SMS to the concerned person based on the details stored in the EEPROM memory. Similarly, the location details of the patent are also sent using the LCD display. Ma'am, அவ்வளவுதான் மேம், முடிஞ்சிச்சு மேம்.
முடிஞ்சிடுச்சு. Okay, good ma. Yeah, very good. Actually, she have explained. Aarti, you have observed only about the temperature alone. Am I correct or not? You
Yes,
can
ma.
take some other thing, okay? Because the temperature alone, she had, I think, she had explained about the. Where is her? Yeah, she explained about very well, but when you see that while the patients were in critical condition, you may take about their ECG, and you all know heart rate is and now the oxygen level, and then pressure level and all, very much important. So there are so many sensors are there in a medical industry to know about these things. But this is the basic circuit. What Aarti explained is it's a basic circuit. And you all know, in our college also got the patent in the 108 ambulance for this. So if any accident met at any place, automatically the GPS will locate that particular place, as well as through that it will identify. And what happened now, the ambulance will go to that particular location, and from that it will identify the patient's health system and all. So one of the pattern we have did, and so many of our students have done this project. Okay, so when accident hits means, they will fix one sensor in the thing. So if it goes beyond that particular stress or strain, automatically what happened, that vehicle were hit somewhere, and and the particular driver has to be protected. So even the driver is or the particular persons inside the car or any vehicle, they are not be in the conscious state. What happened, it will identify the particular location, and automatically the patient's health condition also will be monitored, and it will be sent to the hospital. So that is one of the patent which is approved by Satyabama, and so many students have done the project in this. So Aarti, you have explained the core of that, but we can add some more sensors to monitor the patient's health condition. Very good, ma. Okay, so I will start explaining our cases, our unit 4. Then we will continue with that. Okay, and I have given seminar for who are all the students, ma? Today, who am
Ma'am.
I? Yeah, Anshuri. Yeah, then another. Who is other
Surya.
prepared?
Surya.
Angeline Aishwarya.
Yes, ma'am.
Yeah, have you prepared Angeline?
Yes, ma'am.
Angeline.
Prepared
Okay.
na?
So Angeline Aishwarya and Ansuri Subramanian and Amurdam Harshavardhan, register number 7. Register number 7, Amurdam Harshavardhan. Yesterday, yesterday while I'm calling, repeatedly calling you, you were not replying to me. So I thought you switched on your video, your Zoom class, and you went somewhere. Am I correct or not?
Yes, ma'am.
Yes,
That time
ma'am.
I go.
Okay, today have you prepared for your seminar? I have informed others. You didn't get the message. Okay, leave it. Okay, day after tomorrow you prepare. Are you clear? I'm sure. Okay, and I will allow Ansuri and Angeline at the end. Okay, and I told you on Wednesday. Am I correct or not? Banu Muttamil Shelvi. Actually, Mogana Priya have I explained? Huh? No, Mohana Priya.
Ma'am, today?
Today you are prepared. Huh?
Yes, ma'am.
Okay, if
Little
time
prepare.
permits, you will explain. Mogana Priya, Muttamil Shelvi, Banu Prakash, 3 Nandinis. Okay, so whoever have the time at the end, we will allow you to take. Yeah, and now I think I enabled the waiting room. I thought that's why some of the people can't able to enter. Okay, ma. So I think last class what we discussed, ma'am. Last class what we discussed. Last class what we discussed. RS 232 and yes, anyone tell me last class what we discussed? I think
RS-232 and RS-435.
Yeah, RS-232 and RS-445. We have we have seen in detail about how the line and receiver is there, what are the pins are there, and how the communication is happening between these two, and what is the difference between two. Now today we will see what is distributed embedded system and embedded networking. Okay, other serial communication protocol we will see in the next classes. I2C, SPI, USB, that all we will discuss in the next classes. Today, our focus is distributed embedded system and embedded networking. Are you clear, ma? Okay. Distributed embedded system. You all understand this. The first figure is centralized computing, and the second figure is distributed computing. You all know centralized computing means it's a single point of control. So the mainframe control will take all the thing. Okay, mainframe control where computer will take, and the single point of control will control the other terminals. So what happen? This terminal can access all the resource available here. Can you understand or not? And similarly, all the user can share at all the time with the my single point of control. That is centralized computing. But you all know only a single point of control is in the centralized computing. So any failure is occurs here, what happen? The other terminal which is connected to the mainframe computer cannot be accessible. So the main advantage of having a distributed computing is multiple point of control. So here one network cable that will connect with one workstation, and it will connect with the other workstation, and some other will be as act as a host. So what happen? There will be so many network. So multiple point of control will be there. So multiple point of failure. So for example, if there is any failure, this network link will take the part, and it will connect with the various systems. So what happened? We have a sharing with that. But one disadvantage is here all the resource will be accessible to all, but here whatever available in the workstation only, it will be accessible to. So the main thing is different processor will be there. Okay, so that is the thing. So the main disadvantages is the component are not shared by all the users, but here the components is shared by all the users at the time, but here component will not be shared by all the users. So and similarly, that is it's a single processor, but it is having a different processor. Okay, and it is a single point of control, and it is having a different point of control, and it is a single point of failure, and this is a different point of failure. Okay, and these are the thing. So while we are going with that, we can't able to have a single point of control all over the time. So the main advantage of having a distributor is we can have a multiple point of processor, different processor I can use, then multiple point of controller will be there. Okay, so that is the multiple autonomous components will be there. So that is the advantages of having distributed computing over centralized computing. So we always focus on distributed computing one. Okay, now they have given the definition for distributed system. So what is a distributed system? Now, a collection of independent computers that appears to be used as a single coherent system. So what happened now in our computer field, we always focus on the distributed system because we have a multiple autonomous computer that communicate through a computer. Because now you can see I am connecting here, and I am controlling and I am communicating over through. So you all connected through a distributed computing system. Okay, and so the distributed computing system we can have a many tasks at a time, and so many one or more computer will be involved. Not a single system, not a single task. We have a many task over that. So what are all the distributed computing system? Now, this distributed computing system will increase the network become cheaper as well as faster. So some of the examples where the distributed system now, LAN, we can see local area network, intranet, okay, that is inside the building. In our in our college also, the intranet facility will be there. Database, DBMS, then automatic teller machine, ATM. Okay, internet, our internet worldwide, that is also a best example for the distributed system. And mobile computing, and mobile computing and ubiquitous computing, all are comes under the same. So if each and everything will be connected over that, so distributed system means not only linking the systems alone, so even mobile computing also we were linking through the distributed system. So these are the some common examples. So a collection of independent computer that appears that can connect the various users through a single coherent system. So that single coherent system may be a LAN, it will be there, or we can connect it through a internet or world wide web and all. Okay, and now we were saying mobile computing is also we were using this distributed system. Actually, you understand that distributed system and embedded networking is a pure theoretical. Okay, we are going to see how it is that. So it's a pure theoretical part only. Okay, so what are the advantages of distributed over centralized? The main thing is economical. Okay, because if I fix on mainframe computer, it have a capability to connect all the over system. So that happened to, we have to design a such a big centralized controller. So rather than the distributed system is having a economic and speed, comparing with that, so many network hubs will be there, so the speed of the system is will be high. Then inherent distribution, so for example, they have given that some application is inherently, some more chain will be there. Okay, actually when you see that one best example is Bitcoin will be that, so there will be a blockchain will be there, so that will be inherent distribution will be there. It will be application for some specific application. Okay, reliability. Okay, reliability means if one machine will crashes, we can survive with other system also, so the reliability also get increases. Then incremental growth, so the computing power can be added small incremental. Okay, and then another deriving force, so because once one for system will depend on another, so we have another deriving force will be there. So main advantage is economical, reliable, incremental growth. According with that, it have a high speed and inherent distribution, and it have a deriving force to other system. Okay, mainly for sharing the information. And advantages of distributed over independent pieces, so I told you already, depending on single mainframe system, these are the main. I can share my data, resource also can be shared, communication, flexibility. So these are the main advantage on that. So data also I can share, resource also can share. Okay, because if so many systems are connected, there will be one single printer, I can, through that I can activate my printer also. So communication, and we all know, now the communication will become very easy, through the mail and all we can communicate to so many human beings and all. Then flexibility, due to the our workload we have a, because now we can see that our entire college is working on online mode. So what happened now, each and every department and year have a separate this Zoom link will be there. So we're working on a distributed system, not in a single system. Okay, but what are the issues will happen in the there is will be a transparency. Okay, I told you already, while we are doing that kind of transparency will be there. Then flexibility, reliability, or also we have to take it over the point. And performance, scalability, these are the design issues while I'm going with the distributed systems. Okay, and you have seen this, see, this is my local OS or local operating system. So this is my distributed system, and this is my distributed system layer, middleware, and this is my distributed application layer. So operating system will be there, middleware will be there, and application layer will be there. Okay, and I think we can serve with the ATM. When I'm go with different ATM machines will be there, and some of them will draft, some of them will take the cash, some of them will know the balance and all. So where depending upon the application, there will be a middleware system will be there. So to communicate between these two, distributed system will be a component. These are the three main components they will take. One is systems, and the third layer is application layer, and the middle layer is middleware layer. Okay, actually you understand, distributed system is a wide topic. Actually, they given as a single word, so we were not going in depth. We are going to see what are the important highlights in the distributed system. That alone we are going to see. Okay, now the very important topic is types of distributed system. So we have seen what is distributed system and what is the advantages of distributed over the centralized system. So in distributed, we have a three kind of distributed system: distributed computing, distributed information, distributed pervasive system. Okay, what is distributed computing? I told you, while I am connecting through LAN or intranet, that is distributing. We are connecting the computers, that is comes under cluster computing. So we were connecting the system through. So what happened now, many distributed system, while we are doing this kind of this, some communication will be happen between the system, that is distributed computing system. So they have given the best example is LAN. Then distributed information system. Distributed information system means, I told you, what are the transaction which is happening in the ATM. So what happened now, so wherever it will be there, but we have to collect the information. You may take cash from one ATM, or else you will go and swipe your card somewhere else, but even there will be your informations your account will be credited, all the information will be debited from the account. So that is distributed information system. So wherever you are doing the transaction, all your transactions will be linked into a single account, and from the single account, the money will be debited. So that is distributed information system. Then distributed pervasive system, that I told you, this is our new generation. So in the next generation, we didn't always focus with the computing. Now the mobiles also comes into the picture. So the various OS will be also adapted with the mobile. So smart cities, smart homes, smart highways, smart classrooms are the pervasive systems. Okay. Once again, students, I'll come. Okay. So, so distributed pervasive system is smart cities. Now our India have identified some of the cities, and they are identified the smart cities. Okay, and they were developing, and smart homes. And now we will see, when you enter into the home, one of our applications, when we enter, our face can recognize, and we can enter into the home. Depending upon your voice recognition, the device will on. So all the smart homes, smart highways. And now you have seen that while we are going for the toll and all, also it will be it have a communicate protocol, whether at which road you are crossing, everything will be identified. And smart classroom, it's another. So distributed system is not only through LAN, through information, through pervasive system. So the controller is through connecting the computers, connecting the information, and connecting through the next generation, that is emerging, like mobiles and all also take into the picture. So this, through this only, the embedded system control will come over on the distributed pervasive system. Okay. And I think, can you able to see this few images, ma? It is one of the important, we can classify the centralized, decentralized, and distributed. Centralized means, you have seen, it's a single control. Okay, and through that I am connecting my computers. So okay, that is one single example was given over here. So this is my server, and that is my master, and the remaining and all my computer which is connected to my server, or we can say it as a slave. So this is centralized system. And the next one is decentralized. What is the difference between centralized and decentralized? Now, centralized, we have a single control or single server or single frame system. But here, when I take the decentralized, we have one or two, more than one server or master will be there. So you can see this is one server, this is the next 3, 4, 5, 6, 7 server are there. Okay, and through that server we can connect it to the other computers or other slave. So this is decentralized. So centralized means single server to single node of control, and this is a multiple node of control. And the distributed is nothing but you have seen that the network connection is between all the cable. So we can't say how it is connected. It is always connected to all the system through the network cable. So this is the distributed system. So I think you can understand from the figure what is centralized, what is decentralized, and what is distributed system. Okay. So they are saying what are the examples of centralized and decentralized and distributed system. So I think centralized, the best example is Wikipedia. So when I go on to search on the particular Wikipedia, and there will be an use a client and server architecture, everything will be stored in that particular company only. So it's a massive server. If I give the request, and the server will respond, and the particular article will be displayed. So that is example of centralized system. Okay, so it's a nothing but a client server architecture. So where a single client, single server will be there. According to the client request, automatically what happened, the massive server will get our request, and it will respond to our request, and the particular page will be displayed. That is centralized system. Decentralized, I think the one of the main thing in 2008 or 9, I think so, the Bitcoin become very popular. Still now it is there. So Bitcoin is nothing but it's a digital wallet. Okay, so how we were storing our money in our packet and all now, this is the way how we were storing our money in a digital wallet like a smartphone or computer. The people can save our money. So the single transaction is recorded in a public list, that we used to say blockchain. So I told you, you can't able to understand the Bitcoin concept now, how we were doing the multiple transaction points. Okay, so how we were accessing our money in a ATM or in a mall or somewhere else in a restaurants and all. The same way, Bitcoin is a digital wallet on a smartphone or computer. The people can access, and we can save the money in that. So that is nothing but a blockchain concept. So what happened? Multiple nodes will be there. There I can access the points. So that is decentralized system. Then the distributed system. So distributed system, I told you, all control over all that. So if I am searching my Google, then automatically what happen now, it will fetch the data by our nearby server, and it will display. So that is the Google search system. Even see that our Google search system will support our own. In India, we are searching a Google now. It will display according to our location and all. So this is the examples for centralized, decentralized, and distributed system. Okay, so this will comes into that. Then embedded networking. So distributed system, what are the thing they highlighted? They give only in your syllabus, the word is distributed system, distributed embedded system. So we have compared the centralized and distributed. And what is distributed system, where it is used, what is the advantages of distributed systems, and what is the architecture of distributed. Very simple architecture. One OS will be there, one application will be there, and middleware distributed system layer will be there. Okay, and this is the types of distributed, not only connecting computer information, as well as we are having connection over through the embedded part through the mobile also. Okay, and this is the diagram for centralized, decentralized, and distributed. And I told you the examples for centralized. client server architecture will be there, and every node, this is nothing but we have seen that some multiple single server system will be there. Through that I can able to connect over through the other clients also. And distributed system, I told you, if I'm searching the Google, then I can get the Google search in our location by that. So that is a distributed system. So these are the some examples. Now the next part is embedded networking. Okay, I told you networking is very very important, because without networking we can't able to accomplish any task, or we can't able to connect the other devices. We can't able to share the resources. So if the networking is possible only, everything will become very effective. So if now I am sharing my and I am taking classes, and now if anyone having their PPT, they will share their own PPT and they will share to others. So what happened now, I can perform my task as well as it is bi-directional only. So the network is very very important. I told you the LAN, WAN, MAN. You all know local area network, wide area network, and metropolitan area network. That's why we are saying this will be a smart cities, and it will be available in our campus and all. And wide area network, what we were using now. So through this hub, all our system will be computer. So they have given one best example is telephone network, mobile network, and a computer network. So networking is always to accomplish some task, or to perform some operation, to share the resources over the network. The networking is very very important. Okay, so why network? I told you, if machine is needed only to manipulate and process the data, we can able to only do that process. But linking the system is always essential to exchange my informations. So that is also now we were performing. That's why networking is become popular now. You can see the networking in the system, not only in the companies, not only in the schools and all. Day to day life we were facing this networks, and how to communicate with that, how to communicate the others to get the information, everything. The network is very very important one, and you all understand this. This is the process. Sharing of files and all, we used to say, or communications purpose also we can use, or we can access the information. And you can say that video games also will be in the networking. And these are the some advantages of over that in networks. Okay, so you can see that TCP, actually there are while we are going with computer networks, there are 7 layer of protocol is very very important. But we were not touching on that. We were touching very important protocol, TCP, actually transmission control protocol. So this is very important protocol for a transmission, or we use it to say IP protocol. You see, IP protocol, that is internet protocol. So what happened now, yeah, the embedded system, you have seen that I am connecting my embedded product will be there. So I am connecting my printer, and I am connecting my various server points are there. So through that you have seen that to connect this, the protocol also plays an important role. Apart from that, we need a serial communication protocols also used will be there. So serial communication protocol now, you have seen serial bus protocol. Okay, I2C bus, CAN bus. Okay, and olden days only we use RS-232 and all. Now we the main is Ethernet type protocol. Then universal USB protocol are the very popular protocol. So why they have given networking, distributed computer networking and embedded networking and all now. So this networking protocol, if I want to accomplish, I want to share my data. And while I'm sharing the data, my sharing my data is not a single byte of data, it is a huge range of data. So I want to transfer my huge range of data. Definitely a bus which is used to transfer my data from one system to another system. So I need always a standard protocol. So in this unit you are going to learn about I2C. Anyone remember what is the full form of I2C? Actually, I have given in PIC microcontroller, I have explained this I2C bus. Not in detail. I gave the full form of I2C. Anyone tell what is I square C bus, ma?
Inter-integrated circuits, ma'am.
Very good. CAN bus?
Control area network.
Control area network bus. So mainly in automobile, the CAN bus is very popular, and you will say I square C bus. Okay, and serial bus. Okay, serial bus and all we have seen with RS 232, RS 485 and all we have seen, and USB protocol is universal serial bus protocol is also there. Okay, so to do all my TCP transmission control protocol, I need all this type of embedded networking is also needed. Okay, then this is the different types of network generally have the following points in common. You all know in our telecommunication system we have embedded systems. Now we are in a telephone. Olden days we are in a telephone lines, and now we switch on to the mobile phones. Okay, and we have a computer networking is also possible by means of routers and all. So if I want to connect it in a campus, we use a router and all. While we are going into our home or in our personal, we are connecting through the wide area network. That is a internet protocol plays a vital role. So even see the advanced HVAC, high voltage AC system. So thermostats and all. When you see that nowadays, when we are an electrical engineer, we have to know everything is centralized. We have a centralized grid over system. So what happen now, if there is any pressurized in one grid, automatically it will be given to the other grid. And you all know now we were going for smart grids and all. So smart grids still we were not implemented any over, but now we have a centralized grid. Even India have also met out with the problem like we have a complete blockout in olden days. If the computer, if the power is shut down 2 or 3 days, it's a big problem. We can't able to face that problem and all. So 2 to 3 days complete shutdown. Even in 2012 also we have faced that kind of problems in North India. But now we don't have such a problem, because we have even everything, we have a control, we have a networking, we have a centralized grid over that. So if any one grid is pumped very heavily, automatically what happened, the another grid will supplies to that. So even in India we have a problem on bridging the rivers only. We already bridged the network and all, we bridged already the electricity and all. Only the problem is bridging the rivers. So the different types of network of the following points in common. So you all know server, clients, we were the clients, then connection medium, where we are going, which medium we are connecting. So we all know there is a different service provider will be there. So we will to connect through that medium, and we can share the data. And while we are sharing, the printer will be there, or they are saying only the peripheral devices. And see some of the examples also they have given RFID. And you have seen but the best example is when you see enter into any companies and all, they have this radio frequency identification IDs. So what happen now, automatically if the person will show that ID to that embedded processor, automatically the door will open, and there will be some security authenticated service they will give to enter into that. So you can see that fault monitoring in industries. You have seen there will be an industry in olden days. What happened now, for each and in every part of the industry, some 30 to 40 employees will be there, and they will monitor the particular system. But here nowadays we don't have that. Everything is centralized through PLC and SCADA. So we can sit in one place and we can observe. I think if you have a free time in our nearby college, you can see Arvin dairy system is there. So they have seen that they have a PLC and SCADA system. They will sit in one place and they will observe. If I go on to the industry, and I have seen there is no people will be there around there. So everything they have a single process. So I can find out that tracking and quality control of goods. Now you all know we were receiving the items through the we were see how you people were not getting the network or not. Every time I have to put. So we were receiving the goods through that. Now Amazon, so many industries are very become popular. Okay, and global monitoring, we now itself we all predicting when the wind will blow, when the rain will come, what happen, everything will be there. So global monitoring will be there. So they are saying global monitoring of large buildings. You have seen that when you go for any malls or some secured places, they will note down how long you are staying. Your vehicle will be through your number plate, they will identify each and everything. So now the networking means not only through server client and all. So it is not only to share the data, it is not only to connect, it is not only to printing the informations, it is through embedded system also we were doing the networking. So we are thinking that embedded is happening on a single system, not like that. When I'm going through the hospitalized, now we have all interconnected and all. So what happen, automatic updation will be there. So even blood donation and all, and whoever needed blood bank, they have a connection over there. And when I'm going for one RF through RFID, we can able to identify the attendance of the particular person over the company. Okay, and we have a fault in industries, we are having a very good control. Okay, so automatic control. So I told you the best example which you can have a free time, you can visit nearby industries. And not only Navin, I'm saying, when you go for any industries, even our we were saying transmission, we are generating the electricity. You are seeing that in the olden days, they will go and see whether the boiler is working correctly. I'm saying thermal power station, whether the turbine is working correct. Now we don't have that. When the coal is comes, automatically they have a single window, they can observe everything in a single system. They can observe, okay, now the coal is delivered, now the coal is burned in the boiler, now what is the boiler temperature. Okay, the boiler temperature is okay, whether the boiler is working or not, everything we have a control. So now we have a single point on common, that is we can observe through networking. So networking play a vital role in all over the industries. Okay, uh, what is the time now? 11:50. Okay, ma. Actually, I will explain tomorrow. I will continue the same. I think now the Ansuri is and whom another one told, Ansuri and
Angelin, ma'am.
Angel. Who is taking first, ma? Who is taking first? Have you sent any mail to me? No. Yeah,
No,
I
ma'am.
didn't. Yeah.
Um,
Shall I allow you to share the screen, Angeline?
yes, yes,
Ah,
ma'am.
yeah. Now you share. You can able to share. See, listen, ma. Have you all seen the assignment two in LMS? Yes, reply, ma. Have you seen the assignment? Nobody have seen,
Ma'am.
yeah, yeah. You people try to prepare not only for the assignment. You can write it for your seminar also. Okay. Yeah. Put the full screen mode, ma.
So can you view my screen?
Yes, ma. Slideshow. Slideshow. Go to slideshow. Yeah.
Ma'am.
Yeah, I think
Let's start.
you didn't start from the first. Yeah, yeah. Explain, ma. Please, others,
So,
listen to
hey,
her, ma.
hey everyone, have you all ever wondered about how your city or streets would look in the absence of traffic lights? Wouldn't it be so,
Angeline, your voice is somewhat disturbing, ma.
ma'am?
Yeah, we were hearing some noise over your line.
Ma'am, is it okay?
Yeah, yeah. I think you speak louder. Sometimes that will suppress the noise. Okay.
Can I
Yeah.
start it now, ma'am?
Yeah, yeah. Start, ma.
Hey everyone, have you all ever wondered how would your city or streets would look in the absence of traffic lights? Wouldn't it be so chaotic and miserable, leading to numerous accidents and loss of lives? Yes, and that is why the need for traffic lights arose. Traffic lights was invented in the year 1868 and developed by an American traffic light company in 1914 by placing the red and green lights at the corners of the streets. During that time, the timing or the switching of the traffic lights were controlled manually. So fast forward to the olden days. Now we use the automated traffic light control system. The primary components which we use are LEDs, crystal oscillators, microcontrollers, 7-segment display, IR sensors, and photodiode sensors. So let me just quickly go through the working of each component. The LED, it is of red, yellow, and green color. It is connected to the port 0 pins of the microcontroller, and it is powered by 5-volt power supply. The LED turns on when the pins are high and turns off when the pins are low. The crystal oscillator. It is used to generate clock pulses. It is used to control the flow of data between the building blocks of microcontroller. And the microcontroller, it is used to automatically control the turning on and off of the LED lights. The 7-segment display, which is over here, is a counter display. It displays the time of changing LEDs from one color to another. And the other two components which are present are IR sensors and photodiode sensors. The IR sensor is an electronic device which emits light in order to sense some object, or it can measure heat and detects the motion. Where the photodiode sensor is light-weighted, which converts light energy to electrical or which converts the light energy to electrical voltage or current. So it basically automated light control system consists of 3 units. The display unit, which consists of the LED, lights, and the detector units, which consist of the IR sensors and photodiode sensors, and the third one being the control unit, which is the microcontroller. The display unit consists of 3 LEDs, which are of colors red, yellow, and green, and they are of 12 LEDs of 3 color each. And the detector units is used to detect the presence of the vehicles in front of the IR sensor and photodiode sensor. The control unit is used to detect the presence of the vehicles which are in the front of it, and also calculates the traffic density. And there's another combination of IR sensor which is connected to the transistors. So there are 2 conditions, one being the normal condition and other being the presence of vehicles. The first one is the normal conditions where no vehicles are present on the road. So the IR transmitter transmits light to the photodiode and start conducting. And as it starts conducting, there are a few diodes present here. The transistor also conducts, and it gives low signal to the microcontroller pin. And that makes the LED glow for a specific amount of time. Whereas in the presence of vehicles, the communication between the transmitter and receiver is interrupted, eventually making the conductor to go off state, and the current in the transistor reduces, and the output becomes high logic signal, and there's an increase in the glow time of the green LED. So as the number of vehicles increases, the timing where the LED light is displayed is also increased. And that concludes my topic. Thank you.
Yeah, good ma. Actually, she have explained the traffic light systems. Have you seen? Now the traffic lights is a very important one, and actually everyone is explaining with this software, Proteus software. So I think if you have a free time, you just download it and try to do some simple program and all. Okay, very good, ma. Okay, I'll
Thank you.